Oh, we are recording. All right. So, welcome to Skill Practice A2, the essential pre-algebra skills you need to know. All right, here we go. So, we are comparing two values here. The one on the left is written in scientific notation. The one on the right is a percentage. It's a decimal that has a percentage. The scientific notation on the left, you're going to this 10 to the negative 2 means you slide that decimal 2 places to the left. Over here on the right, this is 0.72%. This is a really small number. This is not even 1%. When you slide this over, any percentage you slide 2 over to make to a pure decimal, you're going to get this as the scientific notation. We have 2 places left. This is a percentage. To make it into a pure decimal, you slide it 2 over. So then when you look at this, you have to look out to the hundredths place. The hundredths place shows that this is going to be greater. Moving on. Any number that is rational. So rational numbers are numbers that can be expressed as a fraction. Anything that can be expressed as a fraction. So all of these. This is a fraction. It's 4. That's rational. This is negative 2. That's rational. All of these are rational. Any of these can be made into a rational number. Irrational numbers are decimals that go on forever with no pattern. The thing is, there's no pattern. If there was a repeating pattern, then it's rational. But that's it, basically. Pi is probably the most famous irrational number. All right, we're going to keep going. I'm going to try to keep this under 15 minutes. All right, estimating square roots. Square root of 7. Square root of 7 is not a perfect square. You can just use Desmos for this. But square root of 7 is not perfect. So a perfect square would be square root of 4 that's right next to it. And square root of 9 is a perfect square. That works out to 2 and 3. So square root of 7 would be between these two. Now the thing you need to remember is it could also be between two negatives, because square root of 4 can also be thought of as negative 2. Square root of 9 could also be thought of as negative 3, because negative 3 times negative 3 gives you 9. So it could also be between the two negatives. Most likely, if they're giving you a positive radical, they're just going to ask about the positives. Square root of 49. Now, most kids are going to say 7, and that's perfectly fine. Square root of 49 is 7. But you can also think of it as negative 7 times negative 7 being 49. Most likely, if they're asking with a positive radical sign, they just want the positive answer. So you could say positive 7, but you could also say negative 7. Moving on. So what is the total cost of a $45.32 shirt that has a 4.5% tax? All right, I'm going to show you 2 ways to do this. The way I used to teach it, or the way I've been teaching it, is through a translation. Basically, you're doing original cost plus the tax amount. And that's where basically you use, this is going to be your tax amount, 4.5% of the cost. You figure out what that is, then you add it in, and you get 47.36. Now, I'm doing some rounding here because it's rounding to the nearest cent. You could also think of this as a proportion. This is a newer way that I've taught it. I've had a couple teacher friends do it this way, and they have really good success. So check this out. If you're paying 100% of the cost plus 4.5% more, you're paying for 104.5% of the cost. So you could set this up. You could do a proportion. 104.5% out of 100 equals blank out of 45.32. And you can do, I call it the ricochet. You do 45.32 times 104.5 divided by 100, and you get an answer. I'll go through that in a little more detail in class. All right. Interest equals principal times rate times time. These are loan amounts. You're borrowing a principal amount of $10,000. Your loan interest is 5%. You're paying it off in a year. So I equals PRT. Interest equals percent times rate times time. You just set up your calculator. Your principal amount is $10,000. Your interest is 5%. You're paying it off in a year. You work it out. It's $500 you're going to pay. So then That just means you're going to pay an extra $500 to borrow $10,000. All right, we're going to move on. We have angle relationships. Angle relationships. Angles 1 and 4. Angle 1 is right here. Angle 4 is right here. They're directly across from each other. That's called vertical. They share a vertex, the tip of the angle. They're directly opposite each other. Now 1 and 3 share a vertex, but they're not opposite each other. And they're always congruent. 1 and 4 are going to have the exact same measurement. That's what congruent means. All right, we're going to keep on going. All right, so we have volume and surface area for cones and pyramids. So they give you a formula sheet. And you'll be given these formulas. You don't have to memorize them. When I was your age, I had to memorize them. What is the surface area of the cone? We're going to look over here and see, hey, this is a cone. Here's the surface area. We need to know what these different measurements are. R is the radius. And L. L is the new one that you might not know. L means slant height. So the slant height's 13. So for surface area, you don't even really need to worry about the regular height. You need to worry about the slant height. So this is the setup. Pi times 5 squared plus pi times 5 times 13. 5 is the radius, so that's why I'm putting it in for R. L is the slant height, that's the 13. We didn't care really about the height. We're going to be using this formula for this problem. And this is what it works out to. We're going to move on. Okay, changing attributes. We've got our original figure here. It's a 1 by 1 by 1, length, width, height. Its volume is 1 cube. Its surface area. How many squares cover it? Well, I see 3 here, but there's also 3 that we don't see. So that's 6 squares total covering the figure. Now, they say triple the height. Well, look at the picture. We tripled the height. Now it's a 1 by 1 by 3. The volume now is a total of 3 blocks. The surface area, well, I see, how many squares do I see? I see 1, 2, 3, 4, 5, 6, 7. I see 7, but there's also 7 that are hidden in this picture. There's 7 that we don't see, so it's a total of 14 squares. So the big thing you need to know is if you triple one of the measurements, the volume will triple, the surface will not triple. You can't just multiply the surface area by 3. Yeah, this side tripled, the front side tripled, but the top stayed the same. So not all of the dimensions triple when you're doing surface area. All right, what transformation took place to get from A to A prime, or the image of A? Well, we've got A here. There's 2 choices that could happen. You could have reflected over Y. That's where you put a mirror down on Y. A was 2 to the left of Y. Now it's 2 to the right. So it could have been a reflection. And then it also could have been a horizontal translation. Horizontal meaning side to side. Translation means slide of positive 4. So I'm going right 4. If it was a translation of negative 4, it would have moved to the left. But translation of 4, 1, 2, 3, 4. Hey, I ended up over there. And that's that. We're going to keep going. Pythagorean Theorem. Once again, if I'm going too fast, write down the skill number. Let me know which ones you want me to explain a little more thoroughly. This is a quick overview. So Pythagorean Theorem, a guy named Pythagoras way back in the day came up with a theorem that says, hey, for any right triangle, if you take A, side A, this short side, and square it, add this other side, B, they're going to add up to whatever C is squared. C is across from the right angle. That's called the hypotenuse. A and B are called legs. So if you take A and square it, B and square it, add them together, you'll get C squared. So with this in mind, if you take this formula, the Pythagorean Theorem, and you set it up like this, hey, we know what A is, we know what B is, we don't know what C is. So I'm going to do this. I'm going to plug in what I know. I'm going to work them out. 6 to the second, A to the second. We get this. We're going to add them together. Well, wait a minute. If C squared is 100, we can figure out what C is real easily. Take the square root of both of them, and you're going to get C equaling 10. area of this trapezoid. They'll give you the formula. Here's the area of the trapezoid. Here's the formula for area of a trapezoid. So now the thing that gets a little bit weird, when you're figuring this out, a lot of kids always think the height is the up and down measurement, the vertical measurement, and it's not. I mean, if you were looking at this, if this was a building, you'd think, oh, the height of this building's 7. But for what we're doing here, you don't think that. Here's what you want to do. The height is always going to be perpendicular between the two parallel sides, and those parallel sides are the bases. So here is the perpendicular to the two parallel sides. So in this case, your height is 4, and the bases are 5 and 7. Okay, your height is always perpendicular to your bases. So there's your height. Then basically, you just work it out. And you can use Desmos to figure this out. We're going to move on. All right, base 1 and base 2. B1, B2, they'll always be parallel. All right, what is the probability of flipping a heads on a coin and rolling an even number on a number cube? Okay, so the probability of heads and even. So flipping a heads on a coin, hopefully now you realize that that's a 1 in 2 chance of flipping a coin. And rolling an even number on a cube, there's, let's see, 2, 4, and 6. There's 3 even numbers on a cube. So basically you're doing 1/2 times 3/6. Now hopefully you're realizing 3 out of 6 is 1 out of 2. Now you could type this directly into Desmos. Hopefully you understand some fraction operations. You're going to get 1 out of 4. You have a 1 in 4 chance, or a 25% chance of this happening. Are these two events independent or dependent? They're going to be independent of each other. One coin, you flipping that coin on heads doesn't make it more likely for the coin. I'm sorry, flipping the coin landing on heads doesn't make your number cube more likely to land on an even number. They're independent of each other. Moving on. Box plots. Okay, so I've got a video that has more detail on how to create these, but knowing how to read them. They used to be called box and whisker plots. This is the box. You got your whiskers down here. This bottom of the whisker is the lower extreme. Now some kids see the graph and they see a 10 and they think that's the lower extreme. No, the whisker ends on 11. The lower quartile is the box part on the left. The median is going to be 16, 17, 18. The median is that line in the middle of the box. And then the upper quartile is the top end of the box, 22. The upper extreme is that highest part of the whisker, not the end of the number line, but the highest part of the whisker, which aligns with 23. So right now we're just worried about reading the box plots. We'll go into deeper detail later on. All right, scatter plots. Looking at this graph, it's going upward from left to right. What kind of relationship is this? Let's see, as x is getting bigger, overall, y is getting bigger also. That's a positive relationship. Hopefully you're remembering something like this when you saw lines and slopes of lines. Okay, simplifying expressions. Simplify the expression below. We have negative 4n plus 7 plus 9n minus 12. Now I'm going to highlight the like terms. We have negative 4n and positive 9n. They both have n's, so they're considered like terms. I'm going to put them together. Notice how I'm including the sign in front of it. When reading the whole statement, you think of it as plus 9n, like 7 plus 9n. But when looking at it individually, you think of it as positive 9n. Positive 9n, negative 4n gives you 5n. 7n minus 12, those are constants. That's going to give you negative 5. There you go. And then we're done. This is where I used to think when I was a kid, oh, what else do you do? I felt really weird leaving it like this, but this expression is simplified. If we knew what n was, we could evaluate this expression. The big thing you need to remember is to remember your integer rules. Don't think 9 and 4 make 13. Don't think 7 and 12 make 19, whatever. So you got to be real careful with that. Just don't forget your integer rules. All right, functions. Is this table a function? Well, an input of 4 gives me an output of 3. That's cool, but then an input of 4 gives me an output of 6. That's the problem. This is not going to be a function. If you give a 4, you should get a 3 and nothing but a 3. If you go and put an input of 4 and then it gives a 6, something weird's happening. It's not a function. One input gives two different outputs. The domain is the set of all the inputs. Now there's two of them here, so all you really need to do is mention one of them, okay? -1 and 4. If you have repeaters, you don't need to mention them. So -1 and 4 are the domain, the set of inputs. The range is the outputs, 1, 3, and 6. Now notice how I'm kind of putting them from least to greatest. That's the ideal thing you should do. All right, we're going to keep going. Linear functions. We have a linear function here. We have y equals -x plus 2. First, we're going to fill in the table. We're going to go ahead and say, oh, negative whatever x is plus 2. That's going to give me 0. And then I'm going to go ahead and plot that point. 2, 0 is an ordered pair. 2 zeros right here. I'm going to put in a -2, negative of -2, and then add 2. That's going to be a positive 2 and 4. There you go. -2, 4. It's going to be right there. -1, I'm going to put in a -1 for x. So negative of -1 plus 2 gives me a positive 3. I'm going to plot that point. You know you're doing this right when your points line up along a straight line. Now, if we're looking for a slope, from one point to the next, we're going down one, right one, down one, right one, down one, right one, down one, right one. Notice how that's basically just -1 over 1. And isn't -1 over 1 the same thing as -1? So we're going to talk about that in a moment. Let's talk about the y-intercept. The y-intercept is where the line hits the y-axis, and it's hitting the y-axis at 2. Now check this out. Our slope was -1. So -x is the same thing as -1. Look at that. -1 over 1 is -1. Check this out. Our constant was 2. Our y-intercept was 2. I've got another video that really explains this a lot more thoroughly. There's some really cool stuff that happens here, though. All right, moving on. Multi-step equations. Linear equations. One variable, no squareds, nothing, no cubes. Just 5n minus 4 equals -3n plus 20. Now, a lot of people panic when they see this. All you got to do is get all your n's on one side and your constants on the other side. Then it looks real familiar. I'm going to go ahead and get rid of my constants this time. You could have gotten rid of the -3n as well. I'm going to go ahead and add 4 to both sides. Boom. Now, I'm going to get rid of this -3n. I'm going to add 3n to both sides. I'm going to get 8n equals 24. I'm going to divide both sides by 8, and I get n equals 3. You're done. You can check it. You can plug this into Desmos on the left of the equation, and then you can plug the right part into Desmos, and they should work out to the same thing. That's 15 minus 4, you get 11. -3 times 3 is 9, plus 20 is 11. You're good. All right. Here we go. Last one. Okay. Same problem, basically, except now you're solving an inequality. I'm going to go ahead and add 4 to both sides. No problem. I'm going to subtract 3n from both sides, because I'm going to get rid of this one on the right. I get -6n. And here we go. Now, this is where it gets a little tricky. I'm dividing out a -6. With inequalities, if your coefficient is negative, you need to reverse the inequality. And then you're going to mark it, open dot, and going to the left. That was a very fast overview of this. I do have more detailed explanations. You can check those out on my YouTube channel.